So I'm going to be solving for you maximum product subarray, medium problem on LeetCode. Given an integer array norms, find a contiguous non-empty subarray within the array that has the largest product and return the product. So this is similar to the Cadence algorithm problem, maximum sum subarray LeetCode problem, in which you track the maximum sum. So in this case, it's the product. So we're going through this array here. 2 times 3 is 6. The largest product we have now is 6. 6 times minus 2 is minus 12. 6 is larger than minus 12, so we keep 6 as our max. Minus 12 times 4 is minus 48, so 6 is still larger, so 6 is our maximum product subarray, formed from these two indices here, or values within the array. The caveat of this problem, however, and what differs it from the maximum sum subarray, is that the effect of negative numbers. You see, with negative numbers in adding, it doesn't have any sort of long-term after effects afterwards with newer elements. Whereas if I was to say, let's say I had an array like this. Let's say I had 1, 2, minus 2, minus 5. And 6. So I go through 1. 1 is currently my maximum product. Then I go minus 2. Minus 2 is not a minimum. If we were just tracking the largest positive number, we would actually lose this. However, minus 2 times minus 5, the minus signs go away. It's now 10. 10 is now our maximum product. 10 times 6 is 60. 60 is our maximum product now. So we actually missed out on this cancellation of minus signs because we were only tracking the largest positive number. So in our view, we would just be going through 1, 1, and then just ignoring everything else, and then 6 would be what we would return instead of the 60, which was the correct answer. We don't want this, so we have to have accounting for negative numbers. So what we could do, instead of just tracking the largest positive number, we can also track the largest negative number, in which case we can do a quick maximum check using Cadence algorithm just to see, will this number be the largest positive number if I was to multiply the array value with the most negative number, and will it cancel out? Or is it a large positive number and I can just see if it's larger by multiplying it with my current maximum value? Obviously, because this is Cadence algorithm, we want to be able to slide across this array without having to, do an extra loop. So we would say our maximum would be either the current number we're at, or the max between the current times max or current times min. Now, the reason why I'm saying this is because let's say I'm at minus 2, for instance. I'm at minus 2. If multiplying it with my current maximum, which is 1, would result in a large number, larger than this current thing, then I can update my value and I can include that into my subarray. And we can include that. This would be the equivalent of taking the coin, or like taking the choice. It's the optimal substructure of the problem, which makes it available to solve via dynamic programming. We can also choose if this is a large negative number. For instance, we're here. If this would be a large negative number, in this case 10, we can check if this current number times the current minimum that we had tracked, which is minus 2. We obviously know that our maximum is 1 so far. Our minimum is minus 2. So this would be the maximum between. This would be the maximum between 1 times minus 5 versus minus 2 times minus 5, and that would give us 10. Alternatively, if we wanted to move across and disregard the previous number and start a new subarray, we could choose our maximum to be the first number. Like we've done here, the maximum starts at the first number. We can actually just choose current number as our maximum to effectively signal that we want to start a new subarray. This is the intelligent sliding nature problem, part of the problem, which means that we don't have to do anything jazzy or something to do an extra loop. And the same logic goes for the minimum, except we're just writing minimum and tracking the minimum that way. And we want to have this number stored in a placeholder so that we're not accidentally updating values within the loop and messing everything up. So I think this is enough to code. Let's say we have a int current max, we have int current min. We want to instantiate this to the first element because that's going to be the first part. We have this equal to the current max, and we have the current min as well. And then we want to say that we have an int result equal to current max, because this is what we're returning anyway. Then we simply iterate over the array. We'll start from 1 since we've already calculated the first one, and then go across num's length and iterate. And then what we want to do is we want to have an int temp max, which is our placeholder value, which is going to be the maximum. Actually, what we want is we want to record the current number, which is equal to nums I. Then we just say int temp max is equal to math.max current versus the maximum between current times current max versus current times current min. So this is the choice part of the problem. And then we can say current min is equal to math.min, current math.min, current times current max, current times current min. We're not gonna update current max and then put it into current min, because that can result in incorrect values being displayed. So then we assign current max to equal current min, to equal temp max. My apologies. And then what we want to do is we want to have result equaling to the maximum between. If we already have the maximum result, we just want to keep that. If we now have a larger result, we need to update the maximum, the result, and then we return the result. So this is pretty efficient. 15 lines of code. I'll submit it. Boom, there we go.